The nature of time. Unraveling the mysteries of past, present, and future. Welcome to WonderWiseHub. In today's mind-provoking video, we unravel the mysteries of the past, present, and future, diving deep into the intriguing world of time. Prepare to embark on a journey through the corridors of perception, as we explore how our own subjectivity shapes our understanding of time. We'll delve into the mind-bending effects of gravity and velocity on time dilation, and investigate the mind-boggling consequences of time travel paradoxes. As we venture into quantum realms, we'll unlock the secrets of how time behaves on the smallest scales of reality. And finally, we'll ponder the concept of irreversibility and the enigmatic arrow of time. So, get ready to challenge your notions and expand your horizons. Don't forget to hit that subscribe button and like this video to join our community of curious minds. Let's dive in together and uncover the nature of time. The perception of time. How our subjective experience shapes our understanding of past, present, and future. Perception of time is a fascinating phenomenon that greatly influences our understanding of the past, present, and future. Our subjective experience shapes the way we perceive and interpret time, leading to unique perspectives and diverse cultural beliefs surrounding this abstract concept. One interesting aspect of the perception of time is the variations in how different cultures view the past, present, and future. For example, some indigenous cultures have a more cyclical perception of time, where events tend to repeat in cycles and history is seen as a continuous loop. In contrast, many Western societies have a linear perception of time, viewing it as a progression from past to present to future. These cultural differences highlight how our subjective experiences and cultural backgrounds play a significant role in shaping our understanding of time. Another intriguing factor that influences our perception of time is our emotional state. Have you ever noticed how time seems to fly when you're having fun, but drags on when you're bored? This phenomenon is known as time perception distortion. Research suggests that when we are engaged and enjoying ourselves, our attention is focused on the present moment, resulting in a distorted perception of time. On the other hand, when we are bored or experiencing unpleasant emotions, our attention tends to wander, leading to a heightened awareness of the passing minutes. Moreover, our perception of time can also be influenced by external factors such as age and life experiences. Studies have shown that as we age, our perception of time speeds up. This could be due to the relative nature of time, where each passing year becomes a smaller fraction of our overall life experience. Additionally, significant life events or traumatic experiences can also impact our perception of time, as they tend to create vivid memories that can either make time appear to slow down or speed up. In conclusion, understanding the perception of time goes beyond a mere objective measurement. It is deeply intertwined with our subjective experience, cultural backgrounds, emotions, and external factors. Our unique perspectives on time shape how we perceive the past, experience the present, and anticipate the future. Exploring these various factors opens up a world of intriguing insights into the mysteries of time and the intricacies of our human perceptions. Time dilation. Exploring the fascinating effects of gravity and velocity on the passage of time. Time dilation is a captivating concept that delves into the intriguing effects of gravity and velocity on the passage of time. It reveals how time can be distorted and experienced differently under different conditions. Let's explore some fascinating facts about time dilation and the reasons behind its existence. One remarkable example of time dilation is gravitational time dilation, which occurs due to the influence of gravity on time. According to Einstein's theory of general relativity, the closer an object is to a massive body, the slower time flows for that object. This means that time moves more slowly for objects in a stronger gravitational field compared to objects in a weaker gravitational field. For instance, clocks on Earth's surface run slightly slower than clocks in space. This effect has been confirmed through precise measurements using atomic clocks. Another mind-bending aspect of time dilation is relativistic time dilation, which arises from the theory of special relativity. According to this theory, time appears to slow down for objects in motion relative to an observer at rest. This phenomenon can be observed at speeds approaching the speed of light. For example, if two astronauts, one on Earth and the other traveling at high velocity in a spacecraft, synchronize their watches before the journey, upon their reunion, they would find that the clock on the spacecraft is slightly behind due to the relativistic time dilation. The underlying reason behind time dilation lies in the fundamental principles of the theory of relativity. The fabric of spacetime is not a static entity but is instead influenced by the presence of mass and energy. Gravity warps spacetime, creating variations in the passage of time. Likewise, velocity affects the perception of time by altering the spacetime framework. These effects, though minuscule in everyday life, become significant when dealing with extremely high speeds or massive objects. The understanding and application of time dilation have practical implications. For instance, it is essential for precise communication and synchronization in global positioning systems, GPS. The satellites in orbit experience time dilation due to both the velocity and the weaker gravitational field, which must be accounted for to maintain accurate positioning data on Earth. In conclusion, time dilation reveals the extraordinary effects of gravity and velocity on the passage of time. This phenomenon is supported by the principles of general and special relativity and has been experimentally confirmed. The interplay between gravity, velocity, and the fabric of spacetime gives rise to fascinating distortions in our perception of time. Exploring these effects not only expands our understanding of the universe but also has practical applications in various scientific endeavors. Time travel paradoxes. Investigating the mind-bending consequences of altering the past or future. Time travel paradoxes have always captivated our imagination, as they explore the mind-bending consequences of altering the past or future. Delving into this intriguing concept, we uncover a myriad of fascinating facts that challenge the conventional understanding of time. Let's delve into the details and reasons behind these paradoxes. One well-known paradox is the grandfather paradox. It suggests that if someone were to travel back in time and prevent their own grandparents from meeting, it would create a contradiction. The individual's birth would be nullified, posing a paradoxical conundrum. This paradox highlights the potential inconsistencies and logical contradictions that arise when we contemplate altering the past. Another perplexing paradox is the bootstrap paradox, also known as the ontological paradox. It involves a cycle of causality, where an object or information appears to be self-created or self-sustained. In simpler terms, it's a paradox of origins. For example, imagine a musician who learns a brilliant musical composition from the future and then travels back in time to the past to publish it under their own name. The question arises, where did the original composition come from? It seemingly has no origin, creating a paradoxical loop in time. The butterfly effect is another intriguing aspect to consider when examining time travel paradoxes. It is the notion that even the tiniest changes in the past can have significant repercussions in the future. The famous example of a butterfly flapping its wings in one part of the world causing a hurricane in another illustrates the delicate interconnectedness of all events. In the context of time travel, altering even the slightest detail in the past could result in cascading effects that drastically reshape the future, potentially leading to unforeseen consequences. These paradoxes arise from the inherent difficulties and logical contradictions associated with time travel. The very idea of changing the past raises questions about the nature of causality, free will, and the consistency of the timeline. The concept of a fixed timeline, where events are predetermined and any attempt to alter them is met with apparent resistance, is one possible explanation for these paradoxes. However, the true nature of time and the possibility of moving through it remains an open question, inviting further exploration and speculation. In summary, time travel paradoxes invite us to contemplate the mind-bending consequences of altering the past or future. The grandfather paradox, the bootstrap paradox, and the butterfly effect provoke thought about the nature of time and causality. These paradoxes challenge our conventional understanding and highlight the intricate complexities involved in tampering with the fabric of time. As we delve deeper into these paradoxes, we are left with a sense of wonder and awe, eagerly seeking answers and unraveling the mysteries of time travel. Quantum time. Unlocking the mysteries of how time behaves on the smallest scales of reality. Quantum time takes us on a fascinating journey into the mysteries of how time behaves on the smallest scales of reality. As we delve into this intriguing realm, we uncover mind-boggling facts that challenge our understanding of time as a linear and constant force. Let's explore the intricate details and reasons behind these quantum anomalies. In the quantum world, time behaves in a peculiar manner. It becomes entangled with other quantum properties, leading to fascinating phenomena such as time dilation and quantum superposition. Time dilation occurs when the passage of time is affected by factors like gravity or velocity. For instance, according to Einstein's theory of relativity, time runs slower in the presence of strong gravitational fields or when moving at high speeds. This dilation of time defies our intuition, creating a sense of wonder about the relative nature of time. Quantum superposition adds another layer of complexity to our understanding of time. In the realm of quantum mechanics, particles can exist in multiple states simultaneously until observed or measured. This means that time can exist in a superposition, where different outcomes coexist until they are resolved through measurement. This mind-bending phenomenon challenges our perception of time as a linear progression, blurring the boundaries between past, present, and future. Furthermore, quantum entanglement introduces a puzzling aspect of time in the quantum domain. Entangled particles become instantaneously interconnected, sharing a unified quantum state regardless of the distance between them. This instantaneous connection seems to defy the constraints of time and space as we perceive them. It raises questions about the true nature of time and its relationship with quantum entanglement. These quantum anomalies hint at a deeper understanding of time beyond our classical perception. They challenge us to reconsider time as a fixed, linear progression and invite us to explore the possibilities of a more intricate and connected reality. Quantum time beckons us to unravel the mysteries of the quantum realm as we strive to comprehend the true nature of time itself. As we venture further into the quantum world, we are left in awe of the mysterious ways in which time behaves on the smallest scales of reality. Time dilation, quantum superposition, and quantum entanglement disrupt our classical notions of time, inviting us to expand our horizons and embrace new perspectives. By unlocking the mysteries of quantum time, we inch closer to unraveling the enigma of time itself, deepening our understanding of the universe and our place within it. The arrow of time. Delving into the concept of irreversibility and why time only seems to move forward. The concept of the arrow of time leads us to explore the fascinating phenomenon of irreversibility and why time appears to only move forward. As we delve into this intriguing topic, we uncover captivating details and reasons that shed light on this fundamental aspect of our existence. One of the reasons behind the arrow of time lies in the second law of thermodynamics. This law states that the entropy, or disorder, of a closed system tends to increase over time. This means that systems evolve from states of lower entropy to higher entropy, leading to the perception of time flowing in a particular direction. The increase in entropy gives rise to irreversible processes, such as the cooling of a hot cup of coffee or the spreading of a drop of ink in water. Another factor contributing to the arrow-like flow of time is the initial conditions of the universe. The Big Bang, which marks the beginning of our universe, is characterized by a state of extremely low entropy. As time progresses, the universe moves away from this low entropy state, and the entropy steadily increases. This progression from a highly ordered state to a more disordered state creates a sense of directionality in time. Moreover, the arrow of time can be associated with the concept of causality. Cause and effect relationships form the basis of our understanding of events unfolding in a particular sequence. Events that have already occurred influence future events, but the reverse is not true. This asymmetry leads to the perception of time moving forward, as causes precede their effects. These intriguing aspects of the arrow of time highlight the irreversibility and apparent unidirectional flow of time. The second law of thermodynamics, the initial conditions of the universe, and the concept of causality all contribute to our perception that time moves only in one direction. By understanding these underlying factors, we gain a deeper appreciation for the nature of time and its role in shaping our experiences and the unfolding of the universe. As we journey further into the exploration of the arrow of time, we uncover the fascinating reasons behind the seemingly irreversible nature of time. The increase in entropy, stemming from the second law of thermodynamics, plays a crucial role in the directionality of time. The progression of the universe from a state of low entropy to high entropy creates a sense of flow in time, with consequences that cannot be undone. Furthermore, the asymmetry of cause and effect is a key factor contributing to our perception of time moving forward. We experience events occurring in a particular order, with causes preceding their effects. This causal relationship reinforces the unidirectional flow of time, as cause and effect relationships are inherently irreversible. In addition, the arrow-like character of time can be linked to the fundamental nature of our universe. The initial conditions of the Big Bang set the stage for the evolution of the universe, with time progressing from a highly ordered state to a state of increasing disorder. This progression gives rise to the arrow of time, as the universe moves inexorably forward. These captivating insights into the concept of the arrow of time deepen our understanding of the irreversibility and apparent unidirectionality of time. The increase in entropy, the asymmetry of cause and effect, and the initial conditions of the universe all converge to create the sense of time moving only forward. Exploring these factors allows us to grasp the intricate nature of time and its profound influence on our perception of reality. The nature of time: unraveling the mysteries of past, present, and future. Thank you for joining us on this captivating journey through the mysteries of time. We hope you've enjoyed exploring the perception of time, time dilation, time travel paradoxes, quantum time, and the arrow of time. If you're craving more thought-provoking content, be sure to check out our other videos on WonderWiseHub. Don't forget to hit that subscribe button and like this video to be part of our community of curious minds. Let's continue unraveling the wonders of the universe together.